Hi, this video is about decomposition reactions. In other words, you have a single reactant and it falls apart into two or more products. So these are some things that you just need to know, the way that these things will decompose. And a lot of them just make perfect sense. So first of all, let's start with a metal carbonate. I think if you remember from a lot of reactions that you've seen in chemistry, when you've got a carbonate, a lot of times you'll get some gas evolution, and that's carbon dioxide gas. So carbonates, always be thinking about CO2 gas. All right, so if you start with a metal carbonate, it will decompose into a metal oxide and the CO2 gas. So let's look at an example of this. You could start with sodium carbonate. Sodium is +1, carbonate is -2, and you might heat this up a bit and you will get the metal oxide, so sodium oxide, and it will generate CO2 gas. Any metal carbonate, and you usually have to heat them up a bit, will do this. So let's go ahead and look at another metal carbonate. Here is magnesium carbonate, and it will decompose into magnesium oxide and carbon dioxide gas. So we're assuming that we're starting with solids here, so we'll keep them together, and these would be solids, and then the gas would go off into the environment. But what about a hydrogen carbonate? So what if we had baking soda, sodium, hydrogen carbonate? I only need one sodium with the hydrogen carbonate. There we go. And you heat this up, and this happens right around 100 degrees. If you heat this up, you will get the metal oxide again. So we'll get some sodium oxide. We'll get our CO2 like we had before. But this time, because we had the hydrogen in here, we will get some water produced as well. So this will be a liquid, and this would be a gas, and this was a solid, and we started with the solid. So this, again, is the net ionic equation. This is not balanced right now. We need a 2 here, and we're going to need a 2 in front of our carbon dioxide. And I think that's balanced. So again, carbonates will decompose, and you're going to be making carbon dioxide gas. So know these two reactions for carbonates. Okay, so let's look at 2 more decomposition reactions. We have a metal hydroxide, and they will decompose into a metal oxide and water. Now wait a minute, a metal oxide and water, the synthesis reaction, if you remember those, give you the metal hydroxide. Check this out. This is the decomposition reaction, but the reverse reaction that you already learned was the synthesis reaction. So if you know one, you know the other. So let's go ahead and look at this. Let's pick a metal hydroxide. Let's go ahead and pick calcium hydroxide. Hydroxide, remember, is -1. And let's start that with a solid. And when that decomposes, it's going to make the metal oxide, so calcium oxide and water. And there you go. So metal hydroxides decompose into the metal oxide and water. And here we've got the metal oxide and water, and the synthesis reaction, or this reverse reaction, we learned was making the metal hydroxide. All right, let's look at oxyacids. So let's look at, say, sulfurous acid. This is why we wanted you to be reviewing your acid names. Oxyacids will decompose into the non-metal oxide. So here it's going to decompose into sulfur dioxide gas and water. So again, we learned in the synthesis reactions that non-metal oxides in water form acids, and you want to make sure that your non-metal does not change oxidation numbers. And so here the sulfur is +4, and over here it is +4. So that's how we know that it generates sulfur dioxide gas. Sometimes these nonmetal oxides, you may hear them referred to as acid anhydrides, because when you add water to them, they make an acid. So these are two more decomposition reactions that you really knew because you knew the reverse reactions that were synthesis reactions. So sulfurous acid decomposes into sulfur dioxide and water. Let's look at another oxyacid. Let's look at carbonic acid. Even if you make carbonic acid or sulfurous acid, when you are, say, doing a double replacement reaction, they will immediately decompose into, our oxyacid is going to give us the nonmetal oxide, so this is going to give us carbon dioxide and water. Okay, so two more reactions for decomposition. Another decomposition reaction you need to know is what chlorates decompose into. They're pretty dangerous to store. A metal chlorate will decompose into the metal chloride and produce oxygen gas, and we know oxygen is flammable. So let's go ahead and see an example of this. This is potassium chlorate. If we heated this up in a test tube, it would decompose into potassium chloride solid, and it would give off oxygen gas. And so now let's go ahead and balance this. I think we need a 2 here, a 2 here, and a 3 here. So that is its net ionic equation. This is probably the most common way to demonstrate a test, a glowing splint test for oxygen. So you would put potassium chlorate in a test tube of solid. You'd heat it up, it would decompose, and then to test for oxygen, you would put a glowing splint in, and what it would do is it would reignite because the oxygen would support the combustion. So anyway, chlorates decompose into the metal chloride and oxygen. Again, you can put any metal here. All right, these next 3 decomposition reactions, they're just kind of ones you just need to know, but they make a lot of sense. Here we have a peroxide, hydrogen peroxide, and peroxides, and they're stored in a dark bottle, and even sunlight can cause this decomposition reaction to happen, but they can decompose into water and oxygen. Again, you have to be careful. The hydrogen peroxide that we buy at the pharmacy is just 3% hydrogen peroxide, so it's not dangerous when it decomposes into the oxygen and water. But in the lab, we can purchase 30% hydrogen peroxide, and then as that decomposes over time, you can generate quite a bit of oxygen, and then it is dangerous. But know this reaction, the hydrogen peroxide decomposes into water and oxygen. That's why we store it in a brown bottle, to slow down this decomposition reaction. Ammonium hydroxide, there's 2 nice polyatomic ions. Ammonium hydroxide decomposes into ammonia, NH3, and water. Again, you just need to know that. Ammonium carbonate. Okay, carbonates, we know, decomposes into carbon dioxide. And so here we go. Ammonium carbonate is going to make ammonia and carbon dioxide and water. So that's the decomposition reaction for ammonium carbonate. And here is the last decomposition reaction. Yay, finally we're done. Probably the most obvious one. If you have a binary compound, so made of 2 elements, if you've got that compound, the elements are together, they can decompose to form the 2 elements. So let's have a look at this. Sodium chloride, and to make this happen, you would do something called electrolysis to make it come apart into the sodium and the chlorine. And be careful when you write these. Remember our diatomics, the 7 diatomic molecules. If you don't remember them, review them from a past video. And so there you go. It decomposed into sodium and chlorine gas. Here's another one. This is mercury 2 oxide. When you heat that up, it will decompose into mercury and give you oxygen gas. There was a question on an AP exam a while ago, and they said if you had this in an open test tube in a hood, of course, because mercury is toxic, and you heated it up, if you started with 2 grams of this. At the end, what mass would you have in your test tube? And we all know about the law of conservation of mass, that matter is not created and destroyed. But in the test tube, only mercury would be present, and oxygen would have gone off into the air. So you may have started with 2 grams of mercury 2 oxide, but you would have been left with less than 2 grams of mercury in your test tube because the oxygen would have gone into the air. Well, anyway, those are decomposition reactions. So you need to learn them, but again, they should just make sense.